Hi guys, in today's video I'm going to be continuing with the AP Calculus BC series. I'm going to be discussing the squeeze theorem, discontinuity, continuity, and the intermediate value theorem. So let's start with the squeeze theorem. So I'm just going to give an example. So it's like a really easy theorem. So let's just say, for example, 1 is less than equal to f of x, and f of x is less than equal to x squared plus 2x plus 2. Find limit x tends to minus 1 f of x. So this is a really easy question, and this is why the squeeze theorem is one of the easiest theorems to learn and understand. So what you do is you just do this limit for the left hand side and right hand side of f of x. So the limit of x tends to minus 1 of 1, which is not a function, is just the constant. So hence it will stay 1, and then limit x tends to minus 1 of x squared plus 2x plus 2. So what you do is you substitute minus 1 in this. So you get 1 minus 2 plus 2. So 1 minus 2 plus 2, which is 1. So this is 1 and this is 1. So that means, so when you do this particular limit, 1 is less than equal to f of x, which is less than equal to 1 again, because we found that this is equal to 1 and that's only for this case. So then what value of f of x satisfies this equation? 1 is the only value, right? Because 1 is greater than equal to this one, and it is less than equal to that. So the answer is 1. So that's essentially what the squeeze theorem is. Now I'm going to be moving on to discontinuities. There are many different types of discontinuities. I'm going to be discussing the first one called removable or point. This is removable or point discontinuity. So I'm going to be drawing graphs for these, so that's easy for you to understand. I was drawing a basic quadratic parabola, but here there's a hole and it's replaced here. So this is a point discontinuity. That means that the graph is going smoothly here, but instead of continuing like this, it's dropping to this point here and then going back up. So there's a discontinuity at this point. Now let's talk about jump discontinuity. So another quadratic, but here there's a filled in circle, but then it jumps to this point. That's why it's called jump discontinuity. So instead of just continuing like this, it jumps to another point and then starts going straight from there. Finally, asymptotic discontinuity. So an asymptote is a point where the graph tends to go to. So it looks like it's going towards there, but it will never actually reach that point. So let me give you an example. I'm just going to draw a straight line. So this is how the graph looks. So you see the straight line, right, which has gaps in it. The graph looks like it's going to go to that point, up and down, but however, it will never reach it. So there is a discontinuity at that value. That is what's called asymptotic discontinuity. So these are the three types of discontinuities which you need to know. Now I'm going to be moving on to continuity. So function f is said to be continuous. So it's continuous at x equals c only if limit x tends to c. So c is a constant. It could be anything like 2, 3, -1, etc. F of x exists. So we know how to check if a function exists or not, right? We've done it in the previous videos. 2, f of c is defined and finally limit x tends to c of f of x is equal to c, is equal to f of c. So these are the three rules which a function must follow if it has to be continuous at a certain point. So I'll give you an easy way. So if you have a graph and they ask you to check if it's continuous or not, all you have to do is trace it with your pen. So this is a simple method. Just trace it with your pen and pencil. If you can't trace it without removing your pen, then without removing your pen off the paper, then it is discontinuous. However, if you can, then it's continuous. So now I'm going to be giving you an example of continuity. So we're given that f of x is equal to x plus 3. So this is a piecewise function if x is less than equal to 2. And then kx plus 6. So kx plus 6, that's just a variable. So we have to find out what the value of k is. We have to find k if limit x. So we have to find k so that f will be continuous at x equals 2. That's what the question says. So at x equals 2, f of x has to be continuous, and we have to find the value of k for which that holds true. So let's just do the testing. So we take 2 minus and 2 plus. So when it's 2 minus, it's less than 2. So you take the first equation, which is x plus 3. 2 plus 3 is 5. Limit x tends to 2 plus kx plus 6. That is equal to 2k. So x is 2, so 2k plus 6. So now we know that if it is continuous, limit x tends to 2 minus has to be equal to limit x tends to 2 plus. So we just equate 5 and 2k plus 6. And now we have this equation, so we can solve for k. So k would be equal to minus 1 by 2. So that's how you solve this type of question. Okay, now I'm going to be moving on to IVT or intermediate value theorem. This is also tested frequently in the AP Calculus BC exam. This is the last topic in limits. So this has some rules. If f of x is continuous, I'm just going to write as CONT. So if f of x is continuous on the closed interval, so it's a closed interval, a comma b. So it's continuous in this closed interval. Second condition is that if f of a, so this value of a, so you input it into the function, is not equal to f of b. And then finally, if k is just the value, and if k is in between f of a and f of b, then there is a number c, between a and b. So not f of a and f of b, it's between a and b, for which f of c equals k. So this is what the IVT is, or intermediate value theorem. So now let's try to solve a question. So I'll do it on the side here so that it'll be easy for you to see. So that you can see the rules and solve the question. So f of x equals 1 by x minus 2. Feel free to pause the video in case you want to solve it before I do. So I'm just writing down the question. And then k equals 1 by 4. So they've given all this. So our question is to find if IVT holds for k. So that's the first question. So we have to prove if the intermediate value theorem holds for this. So we know that the first rule is f of x is continuous at a and b. So we have to first input 5 by 2. So 5 by 2 is a and 7 is b. So 1 divided by 5 by 2 is 2.5 minus 2, which is equal to 1 by 0.5, which is 2. So we just did f of 2.5. And now let's do it for 7, which is 1 minus 7 by 2, which is 1 by 5. So these are our values for f of a and f of b. Wait, let me just draw a partition here. That's easy for us. So we have 2 and 1 by 5. So these are our values for f of a and f of b. So we know that k is 1 by 4, right? So k equals 1 by 4. So the IVT states that k should be in between f of a and f of b. So f of a is 1 by 2 and f of b is 1 by 5. Is 1 by 4 in between this? Yes, it is. Because 1 by 4 is 0.25, 1 by 2 is 0.5, and 1 by 5 is 0.2. So 1.25, so 0.25 is in between. So it does hold true for now. So we have proved that k holds for the IVT. Now the second part says find the value of c. So 1 by, so we know that f of c is equal to k, right? So we just substitute c in the equation. So f of c, so 1 by c minus 2 is equal to k. K is 1 by 4. Now we have equation and we can solve it. So c is equal to 6. So this is our final answer for the value of c. Okay, that's it for today's video, guys. In today's video, I'm done with AP Calculus BC, the first lesson, which is limits. In the next video, I'm going to be starting with derivatives. Thank you.